Imagine standing at the edge of a vast glacial plain. The horizon stretches endlessly white, broken only by jagged mountains of ice reaching toward a pale sky. The air burns your lungs with each breath, sharp and clean in a way our modern atmosphere never is. This is not an alien world. This is Earth, your home, as it appeared just 12,000 years ago. For more than 100,000 years before that moment, ice had dominated our planet. Glaciers 2 miles thick crushed the land beneath their weight. Sea levels sat hundreds of feet lower than today, revealing continental shelves we can now only study through sonar and underwater archaeology. Then something changed, something dramatic. In a geological eyeblink, the great ice retreated. The world transformed with a speed that defies our understanding of natural climate shifts. Massive ice dams collapsed. Entire inland seas drained in catastrophic floods. Coastlines vanished beneath rising waters. Ancient human civilizations faced apocalyptic change, or did they? This is where the mystery deepens. Because scattered across our planet are remnants of advanced prehistoric cultures that somehow thrived during this tumultuous period. Their architectural achievements align with cosmic precision. Their folklore speaks of cataclysmic floods and gods who brought knowledge from beyond. The conventional timeline of human civilization begins after these events. But what if that timeline is fundamentally incomplete? Tonight, we explore the remarkable convergence of evidence suggesting the end of the last ice age wasn't just a climate event, but perhaps the most significant catastrophe in human memory, one that might have reset civilization itself. We'll examine geological anomalies that challenge our understanding of Earth's recent past. We'll consider archaeological discoveries that push human achievement thousands of years earlier than previously thought. And we'll confront the most unsettling question of all. What if the ancient flood myths shared across disconnected cultures weren't myths at all, but a form of inherited trauma, the collective memory of a world drowning as the ice melted? The answers lie in a narrow time window that scientists call the Younger Dryas, a period of radical climate fluctuation when Earth's temperature rose, then plunged, then rose again with shocking abruptness. The evidence points to cosmic impacts, shifting ocean currents, and massive meltwater pulses that remade continents. But it also points to something more profound, a gap in our understanding of who we were before the waters rose. What we find in this investigation challenges not just how we see our planet's natural history, but our place within it. It suggests that human potential and human vulnerability may be far greater than we've allowed ourselves to believe. You've heard the standard human timeline. Primitive hunter-gatherers slowly developing agriculture around 10,000 years ago, then gradually building towards civilization. It's a comforting linear progression. But what if it's fundamentally wrong? What if advanced human cultures thrived during the Ice Age, only to be obliterated so completely by catastrophic flooding that only their most durable monuments and their traumatic memories survived? The clues are etched in stone, buried in seafloor sediments, preserved in ice cores, and hidden in plain sight within our oldest stories. They speak of astronomical knowledge impossible for supposed primitives. They whisper of technologies lost and found again. In the past decade, revolutionary discoveries have forced archaeologists to push human achievement back thousands of years. Göbekli Tepe in Turkey, Gunung Padang in Indonesia, the submerged structures of India's Gulf of Cambay. Each site presents the same puzzle, monumental architecture appearing fully formed with no clear evolutionary path, often precisely oriented to celestial events in periods when humans supposedly lacked even basic agriculture. And each site shares another feature. They date to the tumultuous period around the end of the last ice age, when the world's shorelines were being catastrophically redrawn. The connections don't stop there. The world's most enduring myths, from Mesopotamian, Indian, Greek, Mayan, and countless indigenous traditions, preserve memories of a great flood that nearly ended humanity. Scientists once dismissed these as primitive explanations for local flooding. But the geographic scale and chronological alignment of these stories point to something far more profound, a global catastrophe preserved in cultural memory. Tonight, we will navigate these waters carefully, separating speculation from evidence. We'll examine what the ice cores tell us, what the seafloor reveals, and what ancient monuments are lying within the sky. We'll trace the path of meltwater floods that dwarfed anything in recorded history. Walls of water hundreds of feet high, moving at hurricane speeds across continents, leaving geological scars we can still see today. And we'll consider a disturbing possibility that what we call the dawn of civilization might actually be its restart, a renaissance after a catastrophe so complete that it reset the human journey. Chapter 2. When Ice Worlds Collapse. The end of the last ice age represents the most recent planetary transformation of Earth. Nothing since. Not the rise and fall of empires. Not the Industrial Revolution. Not even our current climate crisis matches its scale and impact on the human story. Yet we discuss it as merely a gradual transition, a gentle warming that slowly turned glacial landscapes into the familiar continents we know today. The evidence tells a far more dramatic story. At its maximum extent around 20,000 years ago, ice sheets covered most of North America down to modern New York City. Northern Europe lay beneath similar frozen expanses. Sea levels sat nearly 400 feet lower than today. Vast landscapes now lost beneath our oceans were exposed. The English Channel was a valley with a river running through it. Indonesia was largely one connected landmass. The Persian Gulf was a fertile valley, not a seaway. These weren't just geographical curiosities. They were homelands for thousands of generations of humans who lived their entire lives never knowing that the ice would retreat or that the seas would rise to claim their world. When warming began, it unleashed forces beyond human comprehension. Imagine watching a continent of ice built up over tens of thousands of years begin to melt. Not gradually, politely, but in catastrophic pulses that defy our modern understanding of climate stability. The stakes of understanding this period correctly couldn't be higher, because the conventional narrative of simple hunter-gatherers gradually developing agriculture after the ice retreated is increasingly at odds with the archaeological record. Sites like Göbekli Tepe in Turkey present a fundamental paradox. Massive, astronomically aligned stone architecture created by people who supposedly lacked the social organization, architectural knowledge, and motivating cosmology to create such structures. The simple chronology taught in schools places the development of agriculture around 10,000 years ago, with cities emerging thousands of years later. But what if this timeline is fundamentally incomplete? What if advanced human cultures had already developed during the Ice Age, only to be devastated so thoroughly by the cataclysmic events of deglaciation that only their most durable monuments survived? This isn't merely an academic question about remote prehistory. It fundamentally changes how we understand human potential and vulnerability. It suggests that civilization isn't a one-way march of progress, but something more fragile and potentially more ancient. The Ice Age ended with a series of catastrophic pulses known as meltwater events. As the massive ice dams that held back glacial lakes failed, they released walls of water that reshaped entire landscapes in days or even hours. The Missoula floods in the American Northwest scoured out the dramatic landscapes of the Columbia River Gorge when ice dams repeatedly failed, sending walls of water 400 feet high racing across the landscape at speeds up to 80 miles per hour. But these were just regional events. Far larger floods occurred when the Laurentide ice sheet collapsed, sending unimaginable volumes of fresh water into the North Atlantic, disrupting ocean currents that regulated global climate. The result was climate whiplash on a scale we can barely comprehend. The world warmed dramatically, then plunged back into near glacial conditions during a period called the Younger Dryas. then warmed again with shocking abruptness about 11,600 years ago. This final warming happened so quickly that ice core records suggest parts of Greenland warmed 10 degrees Celsius, 18 degrees Fahrenheit in a single decade. Modern climate change, as serious as it is, pales in comparison to such an extreme shift. If our own civilization faced such rapid change, the equivalent of New York City suddenly developing the climate of Miami in just 10 years, the disruption would be incalculable. What might it have done to ancient cultures? The clues are written in ancient myths worldwide. From the Epic of Gilgamesh to the biblical Noah, from Native American flood stories to Aboriginal Australian traditions, similar narratives emerge across disconnected cultures. These aren't just stories about water. They're specifically about a world-destroying deluge that came suddenly, spared only a fortunate few, and forever divided history into before and after. They often include astronomical observations and precise geographical details. What if these weren't primitive attempts to explain local flooding, but preserved memories of real catastrophic events? The meltwater pulses and rapid sea level rise that accompanied the end of the Ice Age. The implications extend beyond archaeology. If advanced human cultures existed earlier than we thought, only to be devastated by climate catastrophe, we must reconsider our own civilization's fragility. Our modern world, with its coastal cities and fragile supply chains, might be more vulnerable to climate instability than we care to admit. The past becomes not just an academic curiosity, but a warning. And there's one more unsettling possibility. What if the most important chapters of human achievement lie not ahead of us, but behind us, submerged beneath hundreds of feet of water on continental shelves that were once fertile coastal plains? What if the sea level rise that accompanied the end of the Ice Age didn't just flood landscapes, but erased entire chapters of human ingenuity and cultural development from our collective memory? The world we know emerged from the ice through catastrophe, not gentle transition. Understanding this reality changes everything about how we see our past and perhaps our future. Chapter 3. Frozen Time. The world of the last Ice Age. 20,000 years ago, our planet was almost unrecognizable. During what geologists call the last glacial maximum, ice sheets covered approximately 30% of Earth's land surface. The ice reached heights of over 2 miles in some regions. The weight was so enormous that it physically depressed the Earth's crust beneath it. Even today, parts of northern Canada and Scandinavia are still rebounding upward, rising millimeters each year as they recover from the ice sheet's ancient burden. This wasn't the first ice age Earth had experienced. Our planet has cycled through glacial and interglacial periods for millions of years. But it was the most recent and the only one witnessed by anatomically modern humans with cognitive capabilities like our own. For perspective, the Egyptian pyramids were built about 4,500 years ago. Human occupation at Gagli Tepe dates to roughly 11,500 years ago. The ice began its final retreat around 20,000 years ago. These are all momentary blips in geological time. Yet this glacial world was home to countless generations of our ancestors. Hundreds of thousands of years of human evolution and cultural development occurred during conditions dramatically different from our own temperate world. The ice sheets locked up so much water that sea levels were approximately 120 meters, 394 feet, lower than today. This exposed vast continental shelves, millions of square miles of land that now lie beneath our oceans. These weren't barren wastelands. Many were resource-rich coastal plains, ideal for human habitation. The Persian Gulf was a lush valley with rivers flowing through it. The North Sea was a fertile plain. The coast of India extended dozens of miles beyond its current shoreline. Most critically, these exposed coastal areas would have been prime real estate for human settlement, offering abundant marine resources, fertile soil, and natural harbors. Precisely the places where advanced cultures might have developed. And here we encounter our first major mystery. Despite all our archaeological knowledge, we have almost no direct evidence of these Ice Age coastal civilizations, if they existed, because their homelands now lie under hundreds of feet of seawater. This creates an archaeological blind spot of staggering proportions. Imagine if future archaeologists tried to understand our civilization, but all coastal cities, New York, Tokyo, Shanghai, London, Sydney, had been submerged and rendered inaccessible. They might conclude that humans of our era were primarily rural inland dwellers, missing entirely the centers of our technological and cultural development. We may face precisely this problem when trying to understand Ice Age humanity. The conventional narrative still taught in most classrooms portrays Ice Age humans as primitive hunter-gatherers, living in small bands focused entirely on survival. But this picture is increasingly at odds with the archaeological evidence. We now know that Ice Age humans created sophisticated cave art requiring scaffolding, artificial lighting, and pigment technologies. They crafted musical instruments, developed complex hunting technologies, and maintained trade networks spanning hundreds of miles. The famous cave paintings at Lascaux and Chauvet in France aren't primitive scribbles. They display sophisticated understanding of anatomy, perspective, and motion that wouldn't be equaled in Western art until the Renaissance, 15,000 years later. Even more remarkable are the astronomical alignments found in some Ice Age art and architecture. At sites like Lascaux, researchers have identified star maps and lunar calendars that suggest these supposedly primitive people tracked celestial movements with precision. This raises a profound question. If Ice Age humans were sophisticated enough to create accurate star maps, what other capabilities might they have possessed? And what evidence of their achievements might now lie submerged beneath rising seas? The world of the last Ice Age was also home to remarkable megafauna, creatures that seem almost mythical to modern eyes. Woolly mammoths, saber-toothed cats, giant ground sloths, and cave bears roamed landscapes now transformed beyond recognition. These weren't confined to a few regions. Megafauna thrived across every continent except Antarctica. North America hosted imperial mammoths larger than any modern elephant, along with American lions bigger than their African counterparts today. Then, between roughly 15,000 and 10,000 years ago, something extraordinary happened. In a geological instant, between 70 and 90% of these large animal species went extinct. The timing coincides precisely with the tumultuous end of the Ice Age. Scientists still debate whether human hunting, climate change, disease, or some combination caused this mass extinction. But its timing, overlapping exactly with the meltwater pulses and rapid climate shifts of deglaciation, cannot be coincidental. This mass extinction represents another crucial clue in our mystery. Something profound and devastating happened at the end of the last Ice Age, something that could wipe out species that had survived multiple previous glacial cycles. As the ice retreated, it didn't melt gradually. It collapsed in pulses, creating enormous glacial lakes held back by ice dams. When these dams failed, they released catastrophic floods that transformed landscapes in hours or days. The channeled scablands of Washington state were carved by repeated outburst floods when the ice dam holding back glacial Lake Missoula failed multiple times. Each flood released the equivalent of 10 times the flow of all the rivers in the world combined. Similar megafloods occurred across North America, Europe, and Asia. The Black Sea may have filled catastrophically when Mediterranean waters breached the Bosporus. The English Channel formed when a natural ice dam failed, releasing a massive glacial lake. These weren't gradual events that humans could adapt to over generations. They were sudden catastrophes that would have obliterated everything in their path, potentially wiping away entire cultures and their achievements almost overnight. And herein lies our central paradox. If advanced human cultures had developed during the Ice Age, especially in coastal regions, The cataclysmic events accompanying deglaciation would have been uniquely positioned to erase them from history, not just through direct destruction, but by submerging their homelands beneath hundreds of feet of rising seawater, placing their achievements literally beyond the reach of conventional archaeology until very recently. The Ice Age world wasn't static. It was dynamic, constantly changing as Earth's orbital variations, solar output, and atmospheric composition shifted. Humans witnessed and adapted to these changes for thousands of generations. Chapter 4. The Great Thaw, Evidence of Catastrophe. The first concrete evidence that the end of the Ice Age wasn't a gentle transition comes from the Greenland ice cores. These natural time capsules, formed as annual snowfall compacted into layers of ice, provide a year-by-year record of ancient climate. When scientists test cores, they discovered something shocking. The final warming that ended the Younger Dryas cold period around 11,600 years ago wasn't gradual. In some regions, temperatures increased by 10 degrees Celsius, 18 degrees Fahrenheit within a single decade. For comparison, modern climate change projections, as severe as they are, typically suggest warming of A-4 degrees Celsius over an entire century. The end of the Ice Age saw warming rates at least 20 times faster. Such rapid change would have dramatically altered precipitation patterns, vegetation zones, and animal migration routes. Imagine the disruption if New York suddenly developed the climate of Florida, or if London became as warm as Barcelona, not over centuries, but in a single generation. The ice cores also reveal another critical clue. The atmosphere during this transition contained unusual concentrations of ammonium, nitrate, and other compounds consistent with massive biomass burning and potential cosmic impact material. This suggests that whatever triggered the final warming may have involved extraordinary events, perhaps continent-scale, wildfires and impacts from space, that go far beyond the gradual orbital variations traditionally blamed for glacial cycles. Sea level records provide our second major line of evidence. During the peak of the last ice age, oceans were approximately 120 meters, 394 feet, lower than today. That water returned to the seas not smoothly, but in dramatic pulses. These meltwater pulses saw sea levels rise by as much as 2 to 4 meters, 6.5 to 13 feet, per century, rates that would devastate modern coastal cities. But evidence suggests that at times, the rise may have been even more dramatic. Researchers studying coral reefs in Tahiti have identified periods when sea levels may have risen by several meters in just a few decades, or possibly even faster. Such catastrophic rise would have outpaced human adaptation, swallowing coastal settlements almost overnight. The third line of evidence comes from the mysterious Younger Dryas climate reversal itself. Around 12,900 years ago, as the world was warming and ice was retreating, global temperatures suddenly plunged back to near glacial conditions for about 1,200 years. This cold snap was named for the Arctic wildflower Dryas octopetala that suddenly reappeared in European pollen records as tundra expanded southward again. The temperature drop happened with shocking speed, perhaps within decades or even years. Then, just as mysteriously, around 11,600 years ago, the cold snapped back to warm conditions even more abruptly. This climate whiplash defies conventional explanations and points to extraordinary disruptive events. At precisely the boundary layer marking the beginning of the Younger Dryas, geologists have found an unusual black mat containing nanodiamonds, metallic microspherules, and other materials consistent with a cosmic impact. These same markers appear simultaneously across North America, Europe, and parts of Asia, suggesting an extraordinary event of continental or global scale, possibly an airburst or impact from a fragmenting comet. The Younger Dryas impact hypothesis remains controversial, but even skeptics acknowledge that something extraordinary happened at this boundary. The materials found simply shouldn't exist in these quantities and distributions without some exceptional cause. This potential impact, or series of impacts, may have triggered the cascade of effects that plunged the warming Earth back into near-glacial conditions, including massive wildfires that would have filled the atmosphere with sun-blocking particulates. Evidence of these continent-scale wildfires appears in the geological record, with charcoal layers and carbon deposits suggesting that vast portions of North America burned simultaneously around 12,900 years ago. Such fires would have devastated Ice Age megafauna populations already stressed by changing habitats. They would have destroyed human settlements and hunting territories, forcing mass migrations into unfamiliar landscapes. The fifth line of evidence comes from ancient seafloor landslides. As ice melted and sea levels rose, the changing pressure on continental shelves triggered massive submarine landslides called turbidikes. The Storegga slide off Norway's coast, around 8,200 years ago, displaced enough material to cover all of Scotland to a depth of 8 meters. It generated tsunamis that struck surrounding coastlines with waves up to 20 to 30 meters, 65, 100 feet high. Similar megaslides occurred worldwide during deglaciation, including multiple events in the Mediterranean, Caribbean, and Pacific margins. Each had the potential to generate devastating tsunamis that would have obliterated coastal settlements. Together, these cosmic impacts, meltwater pulses, sea level jumps, and megatsunamis created conditions of environmental catastrophe unlike anything in recorded human history. Yet curiously, this is precisely when the first known monumental architecture appears. Sites like Göbekli Tepe in Turkey feature massive stone pillars weighing up to 20 tons, arranged in precise circular patterns with sophisticated carved reliefs. Conventional archaeology dates them to around 11,600 years ago, exactly when the Younger Dryas ended. The site's builders possessed advanced architectural knowledge, astronomical understanding, and social organization. Yet they supposedly existed before pottery, writing, metal tools, or even agriculture according to conventional timelines. This presents a fundamental paradox. How did hunter-gatherers without draft animals or wheels move and erect stone monoliths heavier than modern concrete trucks? The site appears with no clear evolutionary precursors. Even more puzzling, the iconography at Göbekli Tepe includes animals that had already gone extinct in the region, along with astronomical alignments suggesting precise observations of celestial cycles. Similar anomalous sites have been discovered worldwide, all dating to the same tumultuous period. Gunung Padang in Indonesia, underwater structures in the Gulf of Cambay off India, and now submerged settlements in the Black Sea and Mediterranean. Each presents the same puzzle. Advanced architectural and astronomical knowledge appearing seemingly from nowhere, precisely when Earth was experiencing its most dramatic climate shifts in human history. The conventional explanation that these were created by simple hunter-gatherers who suddenly decided to build monumental structures before developing basic technologies like pottery strains credibility. A more coherent explanation is emerging. These structures might represent the desperate final works of advanced Ice Age cultures, facing catastrophic environmental collapse, or perhaps the recovery efforts of survivors rebuilding after the cataclysm. This brings us to perhaps the most compelling evidence of all: the remarkable consistency of flood myths across completely disconnected ancient cultures worldwide. From Mesopotamia to Mesoamerica, from India to indigenous Australia, similar stories emerge. These aren't just tales of rising water. They specifically describe catastrophic civilization-ending floods that came suddenly, were often preceded by fire or cosmic disturbances, and forever divided human history into before and after. Mainstream archaeology has long dismissed these as primitive explanations for local flooding or metaphorical stories. But their geographical distribution, chronological alignment, and specific shared details suggest something more profound. What if these weren't myths at all? What if they were actual oral histories of the meltwater pulses, cosmic impacts, and rapid sea level rise that accompanied the end of the last ice age? Consider that at current rates of sea level rise, about 3 to 4 millimeters per year, a human lifetime sees seas rise just a few inches. But during meltwater pulses, seas rose hundreds of times faster. An elder could have witnessed shores advance miles inland during their lifetime. Such events would have been so traumatic, so civilization-altering, that they would be remembered and transmitted across generations. Not as geology, but as story. Tales of gods and catastrophe that preserve the essential truth of what happened. And here we approach our central mystery. What if the conventional timeline of human civilization is fundamentally incomplete? What if advanced human cultures had developed during the Ice Age, only to be obliterated by the catastrophic events of deglaciation? What if sites like Göbekli Tepe aren't the beginning of monumental architecture, but the survivors' attempts to preserve knowledge after near extinction? What if our oldest myths aren't metaphorical stories, but traumatic memories of real global catastrophe? The answers may lie beneath hundreds of feet of water on continental shelves worldwide, the very places where Ice Age humans would have built their most advanced settlements, now submerged by the rising seas. Modern underwater archaeology is only beginning to explore these vast submerged landscapes. Already, the findings are extraordinary. Stone structures, organized settlements, and evidence of advanced technologies existing thousands of years earlier than previously thought. Off the coast of India in the Gulf of Cambay, underwater archaeologists have discovered the remains of massive stone structures over 9,500 years old, when the area was supposedly inhabited only by simple hunter-gatherers. Similar finds off the coasts of Japan, Taiwan, and throughout the Mediterranean suggest that what we consider the cradle of civilization may actually just be the high ground where survivors rebuilt after the catastrophic flooding of their original homelands. This evidence converges toward a disturbing possibility that human civilization isn't 6,000 years old, as conventional archaeology suggests, but potentially many thousands of years older, with its earliest chapters now lying beneath the waves. But if that's true, why don't we have clearer evidence? Why don't our history books already reflect this more ancient origin of advanced human achievement? The answer may lie in the nature of catastrophe itself. If the end of the Ice Age brought civilization-ending floods, cosmic impacts, and climate collapse, the survivors would have faced a world transformed beyond recognition. Chapter 5. The Impossible Timeline. Confronting Historical Contradictions. The conventional archaeological timeline places the development of agriculture around 10,000 years ago in the Fertile Crescent, with monumental architecture emerging thousands of years later after settled farming communities established food surpluses. This neat, linear progression forms the foundation of our understanding of human civilization. Agriculture leads to settlements. Settlements lead to specialization. Specialization leads to monumental architecture and complex societies. It's logical, reasonable, and increasingly contradicted by evidence. Sites like Göbekli Tepe in Turkey append this entire sequence. Dating to approximately 11,600 years ago, its massive T-shaped pillars, some weighing over 20 tons, were precisely arranged in circular patterns with sophisticated carvings of animals and abstract symbols. The site's builders demonstrated knowledge of architecture, astronomy, and logistics that shouldn't have existed for thousands of years. Yet, according to conventional archaeology, they were pre-pottery, pre-writing, pre-metallurgy hunter-gatherers without even domestic animals to help move stones. Even more puzzling, the site was deliberately buried around 10,000 years ago, preserved not by accident but by intention. Why would a hunter-gatherer society invest enormous resources in creating monumental architecture, only to bury it completely a few generations later? Göbekli Tepe isn't an isolated anomaly. Gunung Padang in Indonesia, long thought to be a natural hill with a small temple on top, has recently been revealed as something far more extraordinary through geological surveys and limited excavation. Ground-penetrating radar and core samples suggest the entire hill is an artificial construction, a massive, pyramid-like structure built in phases, with the earliest layers dating to around 25,000 years ago, deep in the last ice age. If confirmed, this would push advanced monumental architecture back to a time when humans were supposedly simple hunter-gatherers concerned only with daily survival, and more critically, to a period before the catastrophic events that ended the Ice Age. At Karahan Tepe, another Turkish site near Göbekli Tepe, archaeologists have uncovered equally sophisticated stonework, including a carved human figure emerging from bedrock that would have required thousands of hours of work with stone tools. Underwater structures off Japan's Yonaguni Island present similar puzzles. While some geologists argue they're natural formations, others point to straight edges, right angles, and apparent drainage channels that suggest deliberate human modification of the landscape. These submerged structures now lie at depths that would have been above sea level during the last ice age, suggesting they date to at least 10,000 years ago, long before Japan supposedly developed monumental architecture. Similar underwater anomalies have been identified off the coasts of India, Malta, and Cuba. Each presents the same paradox: apparent architectural sophistication in periods and places where such capabilities supposedly didn't exist. This pattern of evidence challenges not just the timeline of human achievement, but our entire understanding of what our ancestors were capable of during and immediately after the Ice Age. The second major contradiction involves the abrupt disappearance of Ice Age megafauna. Between roughly 15,000 and 10,000 years ago, approximately 70 to 90% of large animal species went extinct across North and South America, Europe, and Australia. The conventional explanation blames either human overhunting, the overkill hypothesis, climate change as the world warmed, or some combination of these factors. But each explanation contains serious flaws when examined closely. If humans were responsible, why did similar megafauna survive previous human migrations? And why did many species that had successfully adapted to multiple previous glacial-interglacial transitions suddenly die out during this particular climate shift? The extinction pattern shows a curious temporal clustering around the onset of the Younger Dryas. Climate reversal approximately 12,900 years ago, precisely when evidence suggests a possible cosmic impact event. Frozen mammoths discovered in Siberia show evidence of flash freezing, with undigested buttercups still in their stomachs and edible flesh preserved for thousands of years. Such rapid preservation requires temperature drops far more sudden than gradual climate change can explain. Some mammoth remains show evidence of trauma, broken bones, and twisted postures inconsistent with normal death. These injuries mirror the effects of powerful blast waves, like those that might follow cosmic impacts or massive volcanic eruptions. A third contradiction emerges when we examine ancient flood myths. Conventional archaeology treats these as metaphorical stories or exaggerated accounts of local flooding. But their global distribution and similar specific details suggest something more profound. Over 200 distinct flood myths exist across human cultures, from the Epic of Gilgamesh to indigenous Australian Dreamtime stories, from Mayan accounts to Greek legends of Deucalion. Many contain remarkably similar elements despite having no historical contact. These shared elements include warnings from divine beings, construction of vessels for survival, specific instructions for preserving knowledge or species, worldwide flooding that covers mountains, and eventual receding of waters revealing a transformed landscape. Most critically, many traditions place these events at a similar time horizon, roughly 10,000 to 12,000 years ago, aligning precisely with the meltwater pulses and rapid sea level rise at the end of the last ice age. If these were merely metaphorical stories or accounts of local flooding, why would disconnected cultures create such similar narratives? And why would they consistently place these events at the same time horizon? A more coherent explanation may be that these stories preserve actual memories of the catastrophic events that accompanied the end of the Ice Age, massive coastal flooding, climate disruption, and possibly cosmic impacts. The fourth contradiction involves out-of-place technological knowledge. Ancient cultures worldwide demonstrated astronomical and mathematical understanding that shouldn't have been possible with their supposed level of technological development. The Antikythera mechanism, discovered in a 2,000-year-old shipwreck, contains gears and calculations that could predict solar and lunar eclipses with remarkable precision. Its metallurgical and mathematical sophistication appears centuries ahead of its time. Ancient Babylonian tablets show knowledge of trigonometry more advanced than previously thought possible. The Piri-Reis map, compiled in 1513 but based on much older sources, shows Antarctica's coastline with accuracy impossible without modern surveying equipment. The most puzzling aspect of these technologies is their non-linear development. Rather than showing steady progress from simple to complex, the archaeological record often reveals sophisticated knowledge appearing suddenly, then sometimes being lost or simplified in later periods. This pattern better matches a scenario where advanced knowledge was preserved from earlier civilizations through catastrophe, with portions lost or misunderstood by later cultures that preserved the techniques without fully comprehending the underlying principles. The final contradiction involves climate stability itself. The conventional view holds that the Holocene, our current geological epoch beginning around 11,700 years ago, has been a period of unusual climate stability that allowed civilization to develop. But this perspective gets the causality backward. What if the remarkable stability of Holocene climate isn't what allowed civilization to develop, but rather the end result of earlier human intervention in Earth systems? Recent research into early agriculture suggests that ancient farming practices may have begun altering atmospheric methane and carbon dioxide levels thousands of years earlier than previously thought, potentially helping stabilize a climate system that was otherwise prone to rapid shifts. This hypothesis, still controversial, but gaining scientific support, suggests our ancestors might have accidentally created climate stability through early agricultural practices, rather than simply benefiting from a lucky period of natural stability. If true, it would mean our entire understanding of the relationship between climate and civilization requires fundamental reconsideration. Human influence on climate wouldn't be a recent phenomenon, but rather a defining feature of the Holocene itself. These 5 major contradictions: anomalously early monumental architecture, clustered megafauna extinction, worldwide flood myths, out-of-place technological knowledge, and questions about climate stability, converge toward a troubling conclusion. Our understanding of human history immediately following the Ice Age may be fundamentally incomplete. The neat, linear progression from hunter-gatherers to farmers to city builders may be not just oversimplified, but potentially backward. What if advanced human cultures had already developed during the Ice Age, only to face catastrophic disruption during deglaciation? What if agriculture wasn't a new invention around 10,000 years ago, but a rediscovery of techniques preserved by survivors? The answers may lie beneath the waves, on continental shelves that were once the prime real estate of Ice Age Earth, now submerged beneath hundreds of feet of water as the seas rose to claim them. Chapter 6: Memories in Stone, Ancient Myths and Anomalous Evidence. The most compelling evidence for catastrophic events at the end of the Ice Age may not be geological at all, but cultural, preserved in the world's oldest and most persistent myths. Stories that once seemed like primitive explanations increasingly align with hard scientific data. The deluge myth appears in over 200 cultural traditions worldwide, each with distinctive local features but sharing a remarkably consistent core narrative. Divine warning, catastrophic flooding, survival of a chosen few, and the rebirth of civilization in a transformed world. In Mesopotamia, the Epic of Gilgamesh describes Utnapishtim being warned by the god Ea about an impending flood. He builds a massive vessel, survives the deluge, and eventually lands on a mountain as the waters recede. The biblical account of Noah follows a similar pattern: divine warning, ark construction, worldwide flooding, and eventual landfall on Mount Ararat. The story specifies that the fountains of the great deep burst forth, suggesting not just rain but geological upheaval. In Hindu tradition, Manu is warned by a fish, an avatar of Vishnu, about a world-cleansing flood. He builds a ship, survives with the help of divine guidance, and eventually repopulates the transformed earth. Greek mythology tells of Deucalion and Pyrrha, who survive Zeus's flood in a chest or ark, landing eventually on Mount Parnassus. To repopulate the world, they throw stones over their shoulders, which become new humans. Indigenous Australian traditions describe a time when the sea rose dramatically, flooding coastal regions and forcing people to retreat inland. Some versions specifically mention that this happened when the ice melted, a remarkable geological insight for an oral tradition. Mayan accounts in the Popol Vuh describe a great flood sent by the storm god, Huracan, from which we derive our word hurricane. The event is tied to astronomical observations and calendar cycles that align with the end of the last ice age. North American indigenous traditions contain dozens of flood accounts, many specifying that the event occurred when the world was still cold or during the ice time, direct references to late glacial conditions. The geographical and cultural diversity of these accounts argues strongly against both coincidence and cultural diffusion. These aren't variations of a single story that spread around the world. They're independent accounts of similar catastrophic events. When we map these flood traditions against the areas most affected by rapid sea level rise and meltwater pulses at the end of the Ice Age, the correlation is striking. The most elaborate flood myths come precisely from regions that experienced the most dramatic flooding. Even more compelling is the chronological alignment. Many traditions place these events in a time frame consistent with the end of the Younger Dryas period around 11,600 years ago, when warming accelerated and sea levels rose dramatically. But myths aren't the only evidence. Anomalous archaeological finds, artifacts that shouldn't exist according to conventional timelines, continue to emerge, challenging our understanding of human capabilities in deep prehistory. The Shigir idol, discovered in a Russian peat bog in 1890 and recently redated to around 12,000 years old, features complex geometric carvings and stylized faces that demonstrate sophisticated, symbolic thinking supposedly beyond the capabilities of its makers. The Nabta Playa stone circle in southern Egypt, dated to approximately 7,000 years ago, contains astronomical alignments marking solstices and equinoxes with precision that implies mathematical understanding and multi-generational observation of celestial cycles. Underwater structures off the coast of western India in the Gulf of Cambay include geometric stone formations and apparent city layouts now submerged under 120 feet of water. Marine archaeologists date them to at least 9,500 years ago. Spherical stone balls found in Costa Rica demonstrate perfect mathematical roundness that would be challenging to achieve even with modern tools. Some weigh several tons, and their purpose remains unknown. The Acambaro figurines, discovered in Mexico in the 1940s, depict what appear to be dinosaurs and extinct megafauna. While many archaeologists dismiss them as modern forgeries, thermoluminescence dating has yielded dates between 4,500 and 2,500 years old. Intriguingly, many indigenous traditions worldwide describe encounters with now extinct creatures in such specific detail that they appear to preserve actual observations, rather than imagination. Australian Aboriginal traditions describe animals matching extinct megafauna with remarkable accuracy. Native American oral histories contain detailed descriptions of extinct animals, like the American lion and short-faced bear, including behavioral traits that would only be known through direct observation. Perhaps most compelling are the architectural anomalies that defy conventional archaeological timelines. Sites demonstrating advanced engineering appear with no clear developmental precursors, suggesting preserved knowledge rather than independent innovation. Göbekli Tepe's 20-ton monoliths show precise astronomical alignments and sophisticated carvings of animals, some of which were already extinct in the region when the site was supposedly built. How did its creators achieve such precision without metal tools or draft animals? The Osirian temple at Abydos, Egypt, contains massive granite blocks cut with such precision that not even a piece of paper can fit between them. The site appears to predate dynastic Egyptian civilization and uses construction techniques not seen in later Egyptian monuments. The Gunung Padang site in Indonesia, traditionally considered a natural hill with a small temple on top, has revealed a far more complex reality through ground-penetrating radar. Core samples from deeper layers have yielded carbon dates as old as 25,000 years. These anomalous sites share several features. They demonstrate knowledge of astronomy, use massive stones with precise fitting, show evidence of sophisticated mathematics, and often incorporate water management systems. Most critically, they frequently appear without clear evolutionary development, sophisticated techniques and knowledge simply appearing fully formed, rather than showing the gradual progression we would expect from independent innovation. This pattern better matches the preservation of advanced knowledge through catastrophe than the conventional model of steady technological progress. It suggests survivors carrying forward sophisticated understanding despite the loss of the infrastructure that supported it. We also find evidence of advanced ancient knowledge in unexpected domains. The pharmaceutical properties of plants described in ancient medical texts, like the Egyptian Ebers Papyrus, often contain effective compounds only recently validated by modern science. Ancient metallurgical techniques sometimes achieved results that remain mysterious until modern times. Damascus steel contained carbon nanotubes and nanowires centuries before modern science could even detect such structures. The astronomical knowledge encoded in ancient monuments frequently demonstrates precision that would require centuries of systematic observation. The positioning of structures like Newgrange in Ireland captures solar alignments that occur only once every 19 years. This pattern of preserved knowledge, appearing fully formed rather than developing gradually, suggests a different model of human history, one where catastrophe repeatedly interrupted progress, forcing survivors to preserve crucial information through periods of reduced technological capability. Ancient texts themselves sometimes directly reference earlier, more advanced epochs. Plato's account of Atlantis describes a sophisticated maritime civilization destroyed by flooding in a single day and night of misfortune. Around 9,600 BCE, precisely when sea levels were rising most rapidly. Hindu cosmology describes previous yugas or world ages of higher development that ended in catastrophe. While often dismissed as metaphorical, these accounts contain specific astronomical observations that align with actual celestial cycles spanning thousands of years. Egyptian texts refer to earlier kingdoms ruled by gods or demigods before the dynastic period. The Turin king list and Palermo stone both mention pre-dynastic rulers with impossibly long reigns, potentially preserving fragmented memories of earlier cultural phases. These accounts have traditionally been dismissed as mythology or political propaganda. But when they align with geological evidence of actual catastrophic events and archaeological anomalies that defy conventional timelines, they take on new significance. Perhaps most compelling are the mathematical and astronomical constants embedded in ancient monuments worldwide. The dimensions of structures from Egypt to Mexico encode values like pi, phi, the golden ratio, and precise measurements of Earth's circumference. The Great Pyramid's dimensions contain mathematical constants that wouldn't be rediscovered by European mathematics for thousands of years. Its positioning demonstrates knowledge of Earth's size and shape with accuracy impossible without sophisticated surveying techniques. Similar mathematical knowledge appears in Mesoamerican sites, Angkor Wat in Cambodia, and megalithic structures across Europe. The consistency of these mathematical encodings suggests deliberate preservation of advanced knowledge rather than coincidence. This convergence of anomalous archaeological evidence, preserved mythological accounts, and encoded mathematical knowledge points toward a troubling possibility that conventional archaeology has fundamentally misunderstood the timeline of human achievement. What if the most significant chapters of human innovation and cultural development occurred during the Ice Age, only to be catastrophically interrupted by the environmental upheavals that accompanied the glaciation? What if the cultures we celebrate as the dawn of civilization, Sumer, dynastic Egypt, the Indus Valley, were not beginnings at all, but rather the recovery efforts of survivors rebuilding after near-extinction level events? Chapter 7. The Drowned World. What hangs in the balance? The stakes of this investigation extend far beyond academic debates about prehistoric chronology. If advanced human cultures existed before the end of the last ice age, our entire understanding of human potential and vulnerability requires fundamental reconsideration. The conventional narrative of human progress portrays our journey as a steady, if uneven, march from primitive beginnings toward ever greater technological sophistication and social complexity. It's a comforting story of incremental improvement, the long upward curve of civilization. But what if that curve isn't always upward? What if human achievement has instead followed a pattern of flourishing, collapse, and partial recovery, with each collapse erasing much of what came before? This alternative model, sometimes called catastrophism, was once dismissed as religious fundamentalism by mainstream archaeology. But mounting evidence suggests that catastrophic events have repeatedly reset human progress throughout our species' existence. The end of the last ice age may represent the most recent and dramatic of these resets, a period of environmental upheaval so extreme that it erased entire landscapes and potentially obliterated advanced ice age cultures. To grasp what's at stake, we must understand the sheer scale of what was lost. When sea levels rose approximately 400 feet, they submerged nearly 10% of Earth's land surface, roughly 3 million square miles, an area larger than the entire United States. These weren't just any lands. They were the most desirable real estate on Ice Age, Earth's coastal plains and river valleys with moderate climates, abundant resources, and natural harbors. Precisely the environments where advanced cultures would most likely develop. If we mapped modern human development patterns onto Ice Age geography, nearly all our major cities would now lie underwater. From Shanghai to New York, London to Mumbai, human civilization consistently clusters along coastlines. This creates an extraordinary archaeological blind spot. We've extensively explored the interiors of continents, the high ground where refugees from coastal flooding would have retreated. But we've barely begun to investigate the submerged landscapes where the most advanced Ice Age cultures would likely have flourished. The technology for such underwater exploration has only recently developed. Remote sensing, underwater robotics, and advanced diving equipment now allow archaeologists to begin systematic surveys of continental shelves and submerged river valleys. And what they're finding is remarkable. Off the coast of Israel, archaeologists discovered a 9,000-year-old settlement complete with houses, fireplaces, and human burials, all now 40 feet underwater. The site contained organic materials like seeds and wood, perfectly preserved in oxygen-poor sediments. Similar discoveries are emerging worldwide. Submerged settlements have been identified off the coasts of Denmark, Greece, India, Japan, and the Americas. Each pushes human architectural sophistication thousands of years earlier than conventional timelines suggest. But these finds represent a tiny fraction of what likely exists. We've explored less than 5% of Earth's oceans in any detail. The continental shelves, where Ice Age settlements would have been concentrated, remain largely unmapped and uninvestigated. This raises a profound question. What if the most important chapters of human achievement lie not in our future, but in our past, submerged beneath hundreds of feet of water when the ice melted and the seas rose? What if the cultures we celebrate as the dawn of civilization, Sumer, dynastic Egypt, the Indus Valley, were not beginnings at all, but rather the traumatized survivors' attempts to rebuild after near extinction? This would explain many archaeological anomalies. Advanced knowledge appearing without clear developmental precursors, sophisticated architectural and astronomical understanding in supposedly primitive cultures, and encoded mathematics that wouldn't be rediscovered for thousands of years. It would also explain the remarkable consistency of flood myths worldwide. These wouldn't be metaphorical stories or exaggerated accounts of local flooding, but rather the traumatized cultural memory of actual catastrophic events that nearly ended humanity. The implications extend beyond archaeology into how we understand human potential and vulnerability today. 3 critical lessons emerge if this alternative timeline proves correct. First, human technological achievement may be far less stable than we assume. If advanced Ice Age cultures were obliterated by environmental catastrophe, leaving only fragments of their knowledge to be preserved by survivors, our own civilization may be equally vulnerable. Our modern world, with its interconnected supply chains, coastal megastheses, and specialized knowledge held by small groups of experts, might collapse more completely under similar environmental stress than we care to admit. Second, the conventional narrative of steady human progress may fundamentally misrepresent our species' journey. Rather than a continuous upward curve, human achievement may better resemble a series of peaks and valleys, with each valley representing catastrophic knowledge loss. This pattern challenges our assumptions about the inevitability of progress. Advanced knowledge and techniques can be lost, not just temporarily, but for thousands of years. The technologies and insights we take for granted might disappear with surprising completeness. Third, and perhaps most profound, is the possibility that our species has faced and survived multiple near-extinction events. This would mean that human resilience, our ability to preserve crucial knowledge through catastrophe, may be our most important evolutionary adaptation. It suggests that cultural transmission mechanisms like myth, ritual, and monumental architecture might serve purposes far beyond what conventional anthropology recognizes as vessels designed to carry essential knowledge through civilizational collapse. The stakes of this investigation also extend to our understanding of current climate change. If human societies have been shaped by abrupt climate shifts in the past, our future may depend on acknowledging this pattern. The warming that ended the last ice age was far more extreme than current climate projections, but it occurred over similar timescales. Sea levels rose hundreds of feet, drowning vast coastal regions. Weather patterns transformed beyond recognition. If advanced cultures existed then, they faced challenges eerily similar to those we confront today. Rising seas threatening coastal settlements, changing precipitation patterns disrupting agriculture, and extreme weather events destroying infrastructure. Their apparent failure to survive intact, or at least to preserve most of their achievements, stands as a sobering warning about our own vulnerability, despite our technological sophistication. But perhaps the most unsettling implication concerns human potential itself. If advanced cultures developed during the Ice Age, only to be reset by catastrophe, what does this suggest about our species' capabilities? It would mean that sophisticated human achievement isn't unique to our modern era or dependent on our current technology. It would suggest that humans have repeatedly reached advanced stages of development throughout our existence, only to face catastrophic setbacks. This pattern would force us to reconsider not just our past, but our future. The upward curve of technological progress that we take for granted might be far more fragile than we assume, vulnerable to environmental shifts, cosmic impacts, or other catastrophes beyond our control. Yet it would also suggest extraordinary human resilience. If our ancestors survived the apocalyptic events at the end of the Ice Age, preserving crucial knowledge through myth, monument, and memory, perhaps we possess greater adaptive capacity than we realize. The flood myths themselves may contain the most important lesson. Across cultures, they share a consistent message. Catastrophe comes with warning signs that most ignore. Only those who recognize the patterns and prepare accordingly survive to rebuild. In this light, the anomalous evidence we've examined isn't just an academic puzzle about the past. It's potentially a warning about our future, encoded by ancestors who experienced firsthand what happens when planetary systems destabilize rapidly. The melting ice sheets of Greenland and Antarctica today echo the deglaciation that transformed Earth 12,000 years ago. The rising seas threatening coastal cities mirror the meltwater pulses that drowned Ice Age landscapes. But unlike our ancestors, we possess the scientific understanding to recognize these patterns. We have the technological capability to document the evidence and preserve knowledge more effectively. We can see the warnings they could only intuit. This creates both responsibility and opportunity. If we correctly interpret the evidence of past catastrophes, we might navigate coming challenges more successfully than our ancestors did, preserving not just survival, but the accumulated wisdom of our species. As we continue our investigation, the evidence will take us deeper into this mystery, examining what happened to survivors of the Ice Age cataclysm, how they preserved crucial knowledge, and what their experience can teach us about our own precarious moment in Earth's history. What emerges isn't just a revised timeline of human achievement, but a fundamentally different understanding of our species' journey, one defined not by steady progress, but by resilience in the face of recurring catastrophe. The truth appears increasingly clear. The end of the last Ice Age wasn't just a climate transition. It was perhaps the most significant catastrophe in human memory, a series of disasters that may have reset civilization and shaped every aspect of our subsequent development. The evidence is written in ice cores and seafloor sediments. It's encoded in ancient monuments and preserved in myth. It's emerging from submerged landscapes worldwide. And it all points toward a disturbing possibility that advanced human achievement has been repeatedly interrupted by environmental catastrophe. As we explore the specific mechanisms of this catastrophe, the meltwater pulses, cosmic impacts, and climate fluctuations that transformed Earth, we'll uncover a story far more dramatic than conventional history acknowledges. A story that doesn't begin with primitive hunter-gatherers slowly discovering agriculture, but rather with advanced cultures facing apocalyptic destruction and the desperate efforts of survivors to preserve their knowledge through the coming Dark Age. Chapter 8. Gathering the Threads, Competing Theories of Catastrophe. As we've explored the evidence for catastrophic events at the end of the last Ice Age, three primary theories have emerged to explain the extraordinary changes that transformed Earth and potentially reset human civilization. Each provides a coherent framework for understanding different aspects of the evidence. The first, and currently most accepted in mainstream geology, is the meltwater pulse theory. This proposes that as ice sheets melted, enormous volumes of fresh water entered the oceans not gradually, but in dramatic pulses when ice dams failed or ice sheets collapsed. The largest of these events, Meltwater Pulse 1A, occurred between 14,600 and 14,300 years ago. Sea levels rose approximately 16 to 25 meters, 52 to 82 feet, globally in just 300 to 500 years, a rate of over 4 centimeters per year, compared to today's 3 to 4 millimeters. Such rapid rise would have inundated coastal settlements with shocking speed. A person could have witnessed shorelines retreat miles inland during a single lifetime. Entire cultures could have been displaced within a few generations. More dramatic still were localized flooding events when ice dams failed. The Missoula floods in North America released the equivalent of 10 times the combined flow of all Earth's rivers. Such events would have been apocalyptically destructive to anyone in their path. The strength of the meltwater pulse theory lies in its solid geological evidence. We can measure ancient shorelines, date seafloor sediments, and model ice sheet collapse with reasonable precision. The physical traces of these events remain clearly visible in the landscape. However, this theory struggles to explain some key anomalies. It doesn't account for the abrupt temperature reversals of the Younger Dryas period, when global warming suddenly shifted back toward glacial conditions before dramatically warming again 1,200 years later. It also doesn't fully explain the clustered extinction of megafauna, the unusual black mat layer found at the Younger Dryas boundary, or the nanodiamonds and microspherules that appear simultaneously across multiple continents around 12,900 years ago. This brings us to our second framework, the Younger Dryas impact hypothesis. First proposed in 2007, this theory suggests that a fragmented comet or asteroid struck or exploded over the northern hemisphere around 12,900 years ago, triggering the Younger Dryas cooling. The impact or airburst would have ignited continent-wide wildfires, injected sunlight-blocking dust into the atmosphere, and potentially destabilized ice sheets, causing catastrophic meltwater release. The environmental consequences would have been apocalyptic for both humans and animals. Evidence for this hypothesis includes nanodiamonds, magnetic spherules, and unusual carbon forms found in a distinct layer precisely at the Younger Dryas boundary across North America, Europe, and parts of Asia. These materials are consistent with cosmic impact but difficult to explain through other processes. Additionally, ice core samples show significant spikes in ammonium, nitrate, and other compounds at this boundary, consistent with massive biomass burning. Geological evidence suggests enormous wildfires coinciding precisely with the onset of Younger Dryas cooling. The impact hypothesis elegantly explains several otherwise puzzling aspects of the Younger Dryas: its abrupt onset, the clustered extinction of megafauna, and the black mat layer containing impact-related materials found at archaeological sites across multiple continents. It also aligns remarkably well with ancient flood myths that frequently describe fire from the sky preceding catastrophic flooding, a sequence that matches precisely what would occur if cosmic impacts triggered ice sheet destabilization and meltwater release. However, the impact hypothesis remains controversial within mainstream geology. Critics note the lack of a clearly identified impact crater, although proponents suggest the impact likely occurred on the now melted Laurentide ice sheet, which would have absorbed the evidence. Recent findings have strengthened the impact case. In 2018, researchers identified a massive impact crater beneath Greenland's Hiawatha Glacier. Though its exact age remains uncertain, it could potentially date to the Younger Dryas boundary. The third framework might be called the climate instability theory. This suggests that Earth's climate system contains inherent tipping points and feedback loops that can trigger rapid, self-reinforcing changes once certain thresholds are crossed. According to this model, as ice sheets melted, the resulting freshwater influx disrupted ocean circulation patterns, particularly the Atlantic Meridional Overturning Circulation, AMAC, that transports warm water northward. This disruption triggered abrupt cooling across the northern hemisphere. The climate instability theory is supported by ocean sediment cores, showing dramatic changes in circulation patterns precisely when freshwater pulses entered the North Atlantic. Computer models confirm that such disruption could trigger rapid cooling. This framework helps explain the climatic whiplash of the Younger Dryas without requiring external triggers like cosmic impacts. It suggests Earth's climate system contains inherent instabilities that can produce rapid, dramatic shifts when pushed beyond certain thresholds. The weakness of this theory lies in timing and specificity. While it explains the general mechanism of abrupt climate change, it struggles to account for the precise clustering of events at the Younger Dryas boundary, the simultaneous appearance of impact markers, extinctions, and cultural disruptions. Each of these frameworks captures important aspects of the evidence, but none fully explains the entire pattern. The most coherent explanation may combine elements of all three. Imagine a cascading catastrophe beginning with cosmic impacts around 12,900 years ago. These trigger massive wildfires and atmospheric cooling, destabilizing ice sheets already weakened by the initial post-glacial warming. The resulting meltwater pulses disrupt ocean circulation, causing further climate instability. This combined model would explain both the abrupt onset and the extended duration of the Younger Dryas cooling. It accounts for the impact markers at the boundary layer, the clustered extinction of megafauna, and the dramatic meltwater pulses evident in the geological record. Most importantly, it helps explain why this particular deglaciation proved so catastrophic compared to previous glacial-interglacial transitions. The combination of external impact and internal climate instability created a perfect storm of environmental change that stressed both human cultures and animal species beyond their adaptive capacity. This integrated catastrophe model also aligns remarkably well with ancient flood myths. The common elements across cultural traditions: fire from the sky, massive flooding, dramatic cooling followed by warming, match precisely the sequence predicted by a combined impact meltwater climate instability scenario. The archaeological implications are profound. If advanced human cultures had developed during the Ice Age, particularly in coastal regions now submerged, this cascading catastrophe would have been uniquely positioned to erase them from history. Coastal settlements would have faced inundation from rising seas. Inland populations would have confronted wildfires, dramatic cooling, ecosystem collapse, and megafauna extinction. The resulting population bottleneck would have preserved only fragments of previous knowledge and achievement. This may explain the archaeological paradox we observed earlier: sophisticated knowledge appearing without clear developmental precursors. Perhaps these weren't new innovations at all, but rather preserved fragments of pre-catastrophe knowledge carried forward by survivors. Sites like Göbekli Tepe, with their advanced astronomy and architecture appearing fully formed, might represent not the beginning of monumental construction, but rather the survivors' desperate attempt to preserve crucial knowledge through a dark age of environmental collapse. The competing theories we've examined aren't mutually exclusive. Each captures important aspects of the evidence. Together, they suggest that the end of the last ice age wasn't merely a climate transition, but a cascading catastrophe that transformed Earth's surface and reset human civilization. Chapter 9. Beyond the Horizon: New Science and Persistent Paradoxes. The past decade has seen an explosion of new scientific approaches, bringing fresh evidence to our investigation. Advanced technologies are allowing researchers to detect archaeological sites beneath oceans, extract ancient DNA from cave sediments, and reconstruct landscapes that haven't existed for thousands of years. Perhaps most revolutionary are the developments in underwater archaeology. New remote sensing technologies like side-scan sonar, multi-beam bathymetry, and sub-bottom profiling allow researchers to identify potential archaeological sites on the seafloor without expensive diving operations. When combined with ROVs, remotely operated vehicles, and advanced diving technology, these methods are revealing an unprecedented view of submerged landscapes, the very places where Ice Age cultures would most likely have developed. The results have been extraordinary. Off the coast of Britain, archaeologists have mapped complete submerged landscapes, including river valleys, hills, and even evidence of human habitation now lying under hundreds of feet of water in the North Sea. Similar surveys in the Persian Gulf have revealed an ancient landscape now completely submerged. A vast plain with river networks that would have been one of the most habitable regions of the Middle East during the last ice age. Off the coast of India in the Gulf of Kalmhat, formerly Cambay, researchers have identified rectilinear structures, drainage systems, and what appear to be foundation walls now lying under 120 feet of water. Carbon dating of dredged materials suggests ages between 7,000 and 9,500 years old. Most dramatic are the structures discovered off Japan's Yonaguni Island. Though some geologists argue they're natural formations, others point to right angles, straight edges, and apparent drainage channels that suggest deliberate human modification of the landscape. These submerged sites create a persistent paradox. They push sophisticated human engineering thousands of years earlier than conventional timelines allow. Yet their very location beneath the waves makes them difficult to study systematically. A second revolutionary approach comes from paleogenomics, the study of ancient DNA. New techniques allow researchers to extract DNA not just from bones, but from cave sediments themselves. This reveals which species were present in an environment even when no physical remains survive. Applied to the Younger Dryas boundary, these methods show dramatic changes in both human and animal populations, precisely when the catastrophic events we've described were occurring. The genetic evidence suggests severe population bottlenecks, near-extinction events for many species. Human DNA from this period shows similar patterns. Many genetic lineages disappear completely, while others show the characteristic signatures of population crashes, followed by rapid expansion, exactly what we would expect from catastrophic events followed by recovery. Perhaps most intriguing, genetic studies of domestic plants and animals suggest that initial domestication of key species may have occurred thousands of years earlier than conventional archaeology recognizes, potentially during the Ice Age itself. This creates another paradox. If the genetic evidence suggests earlier domestication, why don't we find archaeological evidence of agriculture before approximately 10,000 years ago? Unless, of course, those early agricultural sites now lie underwater on the submerged continental shelves. A third technological revolution comes from isotope analysis. By examining the ratio of stable isotopes in ancient materials, researchers can reconstruct temperatures, precipitation patterns, and even human and animal migration routes with unprecedented precision. Applied to the Younger Dryas boundary, these methods confirm the extraordinary rapidity of climate change. Some regions experience temperature shifts of Y-15 degrees Celsius, P-27 degrees Fahrenheit, within decades, rates of change that would devastate modern agricultural systems. Isotope studies of human remains from this period show dramatic shifts in diet and mobility patterns precisely when environmental catastrophes were occurring. People who had been settled suddenly became highly mobile. Diets shifted from diverse to restricted resources. These patterns match exactly what we would expect from populations experiencing catastrophic disruption of their subsistence systems. The desperate adaptation of survivors, rather than the gradual cultural evolution portrayed in conventional archaeology. A fourth breakthrough involves the re-examination of ancient structures using archaeoastronomy, the study of how ancient monuments align with celestial events. New computer modeling allows researchers to reconstruct precisely how the night sky appeared thousands of years ago. Applied to sites like Göbekli Tepe, these methods reveal sophisticated astronomical knowledge encoded in stone. The main pillars align with celestial events, including the heliacal rising of Sirius. Other alignments mark equinoxes, solstices, and even track the precession of the equinoxes over centuries. This creates perhaps the most persistent paradox of all. How did supposedly primitive hunter-gatherers acquire such sophisticated astronomical knowledge? Tracking precession requires multi-generational observation and record-keeping traditionally associated with much later agricultural societies. Unless, of course, this knowledge wasn't newly discovered, but rather preserved from earlier, more advanced cultures disrupted by the catastrophic events at the end of the Ice Age. The astronomical alignments at Göbekli Tepe and similar sites contain another crucial clue. Many appear calibrated to the sky, as it would have appeared not when the monuments were built, but thousands of years earlier, during the Ice Age itself. This suggests these structures weren't just astronomical observatories, but mnemonic devices, stone, computers designed to preserve essential knowledge through catastrophic disruption when other record-keeping methods might have failed. A fifth scientific breakthrough involves re-examination of ancient myths using statistical analysis and cross-cultural comparison. When flood myths from hundreds of cultures are analyzed for specific motifs and details, remarkable patterns emerge. The most widespread and consistent elements don't just describe rising water, but specifically mention fire from the sky, extreme cold followed by warming, the loss of specific animal species, and the preservation of knowledge by survivors, precisely matching the cascading catastrophe model we've developed. Even more remarkably, when these myths are plotted geographically, they show clear correlations with areas most affected by the glaciation events. The most elaborate flood traditions come from precisely those regions that experienced the most dramatic sea level rise and meltwater flooding. This creates another paradox. How could primitive oral traditions preserve accurate memories of specific geological events for over 10,000 years? Unless these weren't metaphorical stories, but rather deliberately constructed vessels for transmitting crucial information through generations. The most persistent paradox involves chronology itself. The conventional archaeological timeline places the development of agriculture around 10,000 years ago, with monumental architecture emerging thousands of years later as farming communities established surpluses. Yet sites like Göbekli Tepe feature massive monumental architecture, dating to 11,600 years ago, before agriculture supposedly developed. Similar anomalies appear worldwide, sophisticated construction techniques appearing without clear developmental precursors. This chronological paradox dissolves if we recognize that conventional archaeology has identified not the beginning of these technologies, but their re-emergence after catastrophic disruption, the survivors' reconstruction rather than original innovation. The new scientific approaches we've examined converge toward a troubling conclusion. The neat, linear progression from hunter-gatherers to farmers to city builders may fundamentally misrepresent human history. Our journey appears far more punctuated by catastrophe than conventional narratives acknowledge. This doesn't mean we must abandon scientific rigor or embrace pseudo-archaeological fantasies. Rather, it suggests that the evidence itself, when examined through multiple disciplinary lenses, tells a more dramatic story than conventional frameworks can accommodate. The emerging picture suggests that human achievement has followed not a steady upward curve, but rather a pattern of development, collapse, and partial recovery. Each collapse erases much of what came before, leaving only fragments to be rediscovered by subsequent generations. This pattern better explains the archaeological and mythological evidence than conventional models. It accounts for the apparent quantum leaps in human knowledge, the preservation of sophisticated astronomical observations in supposedly primitive cultures, and the consistent theme of catastrophic reset in our oldest stories. Most importantly, it suggests that human resilience, our ability to preserve crucial knowledge through civilizational collapse, may be our most important evolutionary adaptation, one we would be wise to nurture as we face our own environmental challenges in the coming century. Chapter 10: The Lost World: Reconstructing Ice Age Civilization. We can now reconstruct with reasonable confidence what likely happened at the end of the last Ice Age and why it matters so profoundly for our understanding of human history and potential. The evidence converges toward a cascading catastrophe that unfolded in several stages between roughly 14,500 and 11,600 years ago. It began with initial warming that destabilized ice sheets, followed by cosmic impacts around 12,900 years ago, triggering dramatic cooling during the Younger Dryas period. This cooling persisted for 1,200 years before reversing with shocking abruptness around 11,600 years ago, a date that aligns precisely with when Plato claimed Atlantis was destroyed, when Göbekli Tepe was constructed, and when numerous cultures worldwide placed their flood myths. The environmental consequences were apocalyptic. Sea levels rose approximately 120 meters, 394 feet in total, drowning nearly 10% of Earth's land surface. Coastlines were treated by dozens or even hundreds of miles. Entire landscapes disappeared beneath the waves. The human consequences were equally profound. Coastal settlements, likely the most advanced of their era, would have faced inundation. Inland populations confronted wildfires, dramatic cooling followed by warming, ecosystem collapse, and megafauna extinction. The resulting population bottleneck preserved only fragments of previous knowledge and achievement. What survived were the most durable monuments, the most crucial practical techniques, and cultural memories encoded in myth and ritual to transmit essential information to future generations. This explains the archaeological paradoxes we've encountered. Advanced knowledge appearing without clear developmental precursors. Sophisticated astronomical understanding in supposedly primitive cultures, and monumental architecture emerging before the supposed development of agriculture. It also explains the remarkable consistency of flood myths worldwide. These aren't metaphorical stories or primitive attempts to explain local flooding. They're the traumatized cultural memory of actual catastrophic events that nearly ended humanity, preserved for over 10,000 years through deliberate oral transmission. Most importantly, it suggests a fundamentally different understanding of human history. What conventional archaeology identifies as the birth of civilization around 6,000 years ago in Mesopotamia, Egypt, and the Indus Valley may actually represent not human society's beginning, but its rebirth after catastrophe. The true dawn of advanced human achievement likely occurred during the Ice Age itself, in coastal regions now submerged beneath hundreds of feet of water. These lost landscapes exposed continental shelves with moderate climates and abundant resources would have been ideal cradles for early civilization. We can glimpse these lost Ice Age cultures through the fragments they left behind. Sophisticated cave art demonstrating advanced understanding of perspective and animal anatomy, complex astronomical knowledge preserved in later monuments, and technologies that appear fully formed without clear precursors. The flooding of these landscapes at the end of the Ice Age represents perhaps the greatest loss of archaeological evidence in human history. Imagine if future archaeologists tried to understand our civilization after all our coastal cities, New York, Tokyo, London, Shanghai, had been submerged and rendered inaccessible. Yet tantalizing evidence of these lost cultures is emerging as underwater archaeology advances. Submerged settlements have been identified off the coasts of Israel, India, Japan, and throughout the Mediterranean, each pushing sophisticated human engineering thousands of years earlier than conventional timelines suggest. Perhaps most compelling is the evidence from Göbekli Tepe in Turkey, dating precisely to 11,600 years ago. When the Younger Dryas ended with shocking abruptness, its massive stone pillars contain sophisticated carvings and precise astronomical alignments that shouldn't exist in a hunter-gatherer society. The site appears to function as a stone computer, a device for preserving essential astronomical knowledge through catastrophe. Its construction coincides exactly with when populations would have been recovering from the environmental apocalypse at the end of the Younger Dryas. Similar sites worldwide, from Malta's megalithic temples to Gunung Padang in Indonesia, shared this pattern. They encode sophisticated knowledge in durable stone, often appearing without clear developmental precursors at chronological horizons associated with recovery from environmental catastrophe. This suggests a radical reframing of human history. The great megalithic structures of prehistory may represent not humanity's first awkward steps toward civilization, but rather the survivors' desperate attempts to preserve crucial knowledge after near extinction. The implications extend far beyond archaeology. If advanced human cultures have been repeatedly reset by environmental catastrophe, our own civilization may be far more vulnerable than we assume, despite our technological sophistication and scientific understanding. Our modern world, with its coastal cities and interconnected supply chains, might collapse more completely under similar environmental stress than we care to admit. The knowledge we take for granted, from mathematics to medicine, astronomy to agriculture, could be lost more thoroughly than seems possible. Yet the evidence also suggests extraordinary human resilience. Our ancestors survived multiple near-extinction events, preserving crucial knowledge through dark ages of environmental collapse. They developed innovative methods for transmitting essential information across generations, when written records might be lost. This resilience may be our most important inheritance, more valuable than any specific technology or technique. The ability to identify what knowledge is most crucial and to devise methods for its preservation through catastrophe may determine whether our own achievements survive future disruptions. The most profound revelation concerns human potential itself. If advanced cultures developed during the Ice Age only to be reset by catastrophe, this suggests that sophisticated human achievement isn't unique to our modern era or dependent on our current technology. It suggests that humans have repeatedly reached advanced stages of development throughout our existence, only to face catastrophic setbacks. The upward curve of technological progress that we take for granted might be far more fragile than we assume. This pattern forces us to reconsider not just our past, but our future. The conventional narrative portrays our journey as a steady, if uneven, march from primitive beginnings toward ever greater technological sophistication and social complexity. But if human history is instead characterized by flourishing, collapse, and partial recovery, with each collapse erasing much of what came before, then our responsibility becomes clear. We must become better not just at innovation, but at preservation. The evidence from the end of the last Ice Age isn't just an academic puzzle about the past. It's potentially a warning about our future, encoded by ancestors who experienced firsthand what happens when planetary systems destabilize rapidly. As we face our own environmental challenges, climate change, biodiversity loss, resource depletion, the lessons from this investigation become urgent. The civilizations that survive aren't necessarily those with the most advanced technology, but those most adaptable to environmental change. The true revelation isn't just that advanced Ice Age cultures likely existed and were reset by catastrophe. It's that this pattern has potentially repeated multiple times throughout human existence, and that we may be facing another such inflection point in our own time. The choice before us is clear. Will we learn from this cycle of achievement and collapse? Or will future archaeologists puzzle over our ruins, wondering how a culture with such advanced technology failed to preserve its achievements through environmental change? As we conclude our journey through the tumultuous end of the last Ice Age, we're left with a profoundly different understanding of human history and potential. The neat, linear progression from primitive hunter-gatherers to modern technological society appears increasingly to be a comforting fiction. The evidence instead suggests a pattern of flourishing, catastrophe, and partial recovery, with each recovery building upon fragments preserved from previous achievements. This cycle has potentially repeated multiple times throughout human existence, with the end of the last Ice Age representing only the most recent reset. What conventional archaeology identifies as the birth of civilization in Mesopotamia, Egypt, And the Indus Valley may actually represent not humanity's beginning, but its rebirth. The recovery efforts of survivors rebuilding after near-extinction level events erased much of what came before. The true dawn of advanced human achievement likely occurred during the Ice Age itself, in coastal regions now submerged beneath hundreds of feet of water. As underwater archaeology advances, we're beginning to glimpse these lost worlds, and they're transforming our understanding of what our ancestors achieved. Perhaps most profound is the realization that our oldest myths may contain more truth than we've acknowledged. The flood stories shared across hundreds of cultures worldwide appear increasingly to preserve actual memories of the catastrophic events that accompanied the glaciation, a form of cultural PTSD transmitted across more than 10,000 years. This perspective doesn't diminish human achievement, it magnifies it. It suggests our ancestors weren't just clever inventors, but also resilient survivors who developed innovative methods for preserving crucial knowledge through dark ages of environmental collapse. As we face our own environmental challenges in the coming century, this resilience may prove our most important inheritance. The ability to identify what knowledge is most crucial and to devise methods for its preservation through catastrophe may determine whether our own achievements endure. The rising waters that drowned Ice Age landscapes echo in our current predicament. As climate change accelerates, we too face rising seas, shifting weather patterns, and potential ecosystem collapse. The difference is that we can see it coming, if we choose to look. The question isn't whether advanced human cultures have existed in the past. The evidence increasingly suggests they have, potentially multiple times. The question is whether our current civilization will prove more adaptable to environmental change than those that came before us. Subscribe to join us as we continue exploring these hidden patterns in human history, the cycles of achievement and collapse that shaped our journey, and the remarkable resilience that might yet carry our knowledge into the deep future, whatever catastrophes await us there.